Hi students, welcome to Vedantu NEET English. I am Diksha Kaushal, your chemistry master teacher. So wait a minute, let me wait for students to join in. Wait a minute, tell me if I am visible, if I am audible. Okay. Hi Sneha, hello Bhagya. So as you all know, we were about to do our solution chapter, but exactly what happened, the studio, there were some technical problems. Because of that, little bit some part or some portion of solution chapters was left, right? So today we are going to cover that, complete that particular thing. Now what was left here? Colligative property, from where short the question will be asked, right? That was left. So today we are going to talk about colligative property. What are the numericals that I ask from colligative properties, right? Okay, yes everybody, so this is going to be sheing. Okay, so do I look like she? Do I look like a ghost? Yeah, the ghost is here. The ghost is someone else. So let me show you the ghost as well. If you have seen Shreyas sir video, you know that who is she, right? Who is she? She is your fears, your fears of different subjects, your insecurities, demotivation that you feel, all of that is she, right? So to fade away that she, what we need, right? What we need? We need someone to solve our problem. So I'm very excited to show you one thing that is very close to my heart, right? So these are basically the flashcards, right? QR quick revision cards. So this is NEET NCERT on the go chemistry, right? As you can see, these are chemistry flashcards, right? So these chemistry flashcards, okay, which chapter you want to see? Okay, we are doing solution chapter, is it? So let us see solution chapter itself, right? Let us see solution. See how beautifully these flashcards they have made, right? This is Bohr model, Lee-Chatelier principle, PB, battery. This is chemical reaction, this is coordination chemistry. Which chapter you want me to show you? Which chapter? Do you want to see solution chapter? Let us see concentration terms here, okay? Let us see concentration terms, because this is so beautifully arranged. I don't want to spoil this, right? So basically, yeah, can you see this? Can you see this? Yeah, I was so like, it's so beautiful, no? Yeah. So this is some basic concepts of chemistry, right? All the formulas will be written in this way. All the formulas will be written in this way. Yes. Right, so this is one of the beautiful things that I have seen regarding chemistry. These are so beautifully arranged, so beautifully written here. I hope so that you're able to see this. If I show you organic chemistry, right? You want to see organic chemistry reactions. Wait a minute. So many flashcards, yeah. This is thermodynamics. Okay, let me see. This is kinetics, coordination, periodic. Okay. Wait a minute. Which chapter, everybody? Chemistry is there, yes, chemistry is there. Okay, let me show you thermodynamics, because there are so many things I am not able to, because there are so many flashcards, yeah? It's a like set amount of variety, see? Okay, so that's why I'm not able to take out all of them, but I'll show you like thermodynamics. You have this page, right? In this format, in very short form, the notes are written, right? Basically flashcards. This is a very good thing for revision. Like you want to revise thermodynamics, you'll just take out 2-3 cards and you will be able to revise full formulas, important points of that chapter. So I think this is a must purchase for you. And what is the offer that you are getting on flashcards? Let me tell you. Okay, the same way you have organic chemistry flashcards, practical chemistry, biology, right? So what you will get? Fulfill your dreams with flashcards. And what is the price of this? Let us see what is the price. Earlier it was 1999. Then it was 1554. But because of this festive season, as we all know, Diwali is the most very close to our heart, right? Diwali is very close to it. Diwali, you see, you go outside, you will see festive vibes will be there. So that is why festive vibes are there also in your Vedantu, right? So that is your 1321, right? So you are getting, the product which was at 2000 at 1321, right? So that is a great deal, and that is valid only till Diwali. That is, I think, 2nd of November till this is valid, right? And one more, why favorite thing is this NCERT Tejas, right? NCERT Tejas, right? We are ready to take off. So now, actually, I'll tell you a funny story about this NCERT Tejas. So when I was coming back from Bangalore, so what happened, no? Because of this Tejas, right? Because it's such a heavy book, right? So much content is there in this particular book. So what happened, my bag was supposed to be like, it should be 15 kilograms, right? But it was more than that. This the airport security, they said that, okay, can you take out 2-3 kilograms out of your bag? So I was taking out in that airport, I was sitting, right, my bag fully open, I was taking out my jeans, everything, right? So then I thought, okay, what must be, how much this book must weigh, right? It's not 2-3 kgs. But then airport security told me that your book, it's 2-3 kilograms, right? It's 2 kilograms. Yeah, it was 2 kilograms. So I took it out on my hand. Then I was like, okay, this Tejas is so useful that so much content you have in this book that I had to take it out of my bag, right? So much content was there, right? So if you talk about your short notes, if you talk about these short notes, these kind of short notes are there, right? Then if you talk about, it's so heavy. Shreya sir is right. We can do gymming, right? So these kind of short notes in the form of tables, you will see in the form of tables, right? Then you will have, wait a minute, then you will have NCERT based questions, right? NCERT based questions, right? You will have NCERT based questions, you will have statement type questions, you will have assertion reasoning questions, right? So different types of questions will be there, and proper NCERT solutions are also given to you, and you have this QR this QR code also if you find any error or if you want to see the solution, right? So everything is there. So I would advise you that if you want to ask your parents for a gift, right, then ask this gift. This is the best gift for you, right? My team gave me this gift, and this is such a, flashcards are very close to my heart. Then obviously for practice you need to have a book. So Tejas book is a very nice book. And why hard copy of that book? Because you can't strain your eyes so much, right? So I would really advise you, invest on this thing this Diwali, right? You should ask your parents to get you this gift, right? Because they will also feel happy that my kid is asking for this kind of gift. Don't waste your money on crackers. Don't waste your money to pollute the environment. Rather, utilize your money, invest your money in something good. You go out, right? You will say, I want crackers. You will take 2,000-3,000 of crackers, right? You will burn it in the night, right? What will happen? You are polluting the environment, right? And also you are wasting your money as well. Not your money, your parents' money. In this way, you are not polluting the environment. You are actually gaining something out of it. So better to invest in something good than in investing in giving your money for crackers or something like that, right? So that is my genuine advice to you. Please celebrate green Diwali. Please save this earth, because already it's so much pollution out there. Still, I don't know why people love using crackers. Don't know what's the reason behind that. Why? Okay. Now, next thing is, students, if you want to have DNA batch plus Tejas, right? Then DNA batch with Tejas is 2,999. Only Tejas will cost you 1,600. So by adding some more amount, right, around 14,000, 1,400, you will get DNA batch also. So which is a very good offer, right? Okay, so DNA batch, it's like we are enjoying totally physical chemistry we are doing right now, and we are about to start the practicing as well, practicing questions as well. So I would advise you to purchase DNA plus Tejas. That is my advice to you, right? If you want to purchase Tejas, that is a must for you. Then purchase, instead of this, I would say purchase DNA batch, right? Along with that. If you're already enrolled in DNA batch, then you can just go for Tejas, right? Then you can just, then obviously you will not take DNA plus Tejas, right? But this thing is the must, right? This is the must, without even a single thought. Give it a try, right? Okay, you are totally going to love it. Trust me on that, right? Okay, so now let us see solution chapters. Right? Let us start the solution chapter. Not start, let us start the colligative property, what is Vont Hoff factor, all the things about that. Right? So everybody in the chat box, shall we start the class? Dual process, 4 reading and 4. Yes. Okay, all subjects we are talking about, not single subject, right? Yes, Sukanya, all subjects. Okay. So now let us see what is colligative property. Everybody give me that high five, Josh, energy in the chat box. Yes. Happy Diwali. I'm going to wish you tomorrow as well, right? Yes. Advance happy Diwali. And I really pray to God, because Diwali is such a, it comes in such a positivity comes from Diwali, right? Whenever we are celebrating, everyone is wishing for each other. We are celebrating with our friends, with our relatives, exchanging gifts, right? That's such a beautiful thing. Right? So it is basically the biggest festival, right? So I just pray to God that you celebrate your next Diwali in your dream medical college with your friends, who are going to be future doctors, right? I really pray for that. But for that, right now, invest in something good, right? Okay, so now let us start. First is, what is exactly colligative property? So anybody, what is colligative property? Colligative property just means that the thing which is dependent on number of, not number of moles, you can say number of moles of solute, which depends on the number of particles of solute, right? That is called the colligative property. Solute is, for example, you have a beaker, you have water in it, you're adding sugar to it. Now that sugar is, which is in minimum quality, which is in less quantity, that is called the solute. So when you're adding solute, that solute, if your colligative property, different types of physical properties we have, out of that, some of them are colligative property. And colligative property, the definition says that in which that property is directly proportional to the number of moles of the solute. Or you can say not number of moles, you can just write that is proportional to the moles of the solute, that is proportional to the solute, right? Just simple that thing, right? Now, there are basically 4 colligative properties. First is relative lowering in vapor pressure. Second is elevation in boiling point. Third is depression in freezing point. Then you have osmotic pressure. So one by one, we will talk about all the properties. First property is relative lowering in vapor pressure, right? First property is relative lowering in vapor pressure. So tell me one thing. For example, you are sitting alone, you are studying, you are very curious that what is happening, ma'am, naming reaction, I will do everything, ma'am, I will do this, I will do that, ma'am, I'll do everything, ma'am, I am sitting alone, I don't care, I am fully focused, ma'am. Then your friend arrived. Friend is who? Friend is solute. Here solvent was sitting alone. Here solvent was sitting alone. And in this, solute will arrive. Okay, solvent was sitting alone. Solute will be like, hey bro, I am here, right? So this will become a solution which has solute and which has a solvent. Now tell me one thing. You were sitting around, you were like, okay, I want to read out this flashcard. Okay, I will read out this flashcard. I will read out this flashcard. This is what you were doing. And then your friend arrived. He's like, oh my God, what are you doing? Why? Diwali season. Let's burn crackers. Why you want to have these flashcards? Now tell me what will happen. Your friend will interfere with your studies, right? your friend, this solute will interfere with this solvent, right? For example, here I am saying your pressure, your focus was P naught, and here it is P, right? Here it is P. This is called the vapor pressure. This is called the vapor pressure of pure solvent, and this is called the partial vapor pressure when you are sitting with your friend. Now tell me, in which the focus is more? When you are sitting alone or when you are sitting with your friends? When you have more focus on studies. For example, you are sitting with your friends, you have so many flashcards. Instead of reading this, you will start playing cards. You start playing cards. You will be like, okay, your mind, let's see who wins. You start playing cards, right? But when you are sitting alone and you will start reading these cards, what is exactly happening here, right? Okay. Yes, from this I got a very beautiful thing, right? Oh my God. DNF block exceptions. DNF block in one page. Isn't it beautiful? Are you able to see this? Are you able to see this? Wait a minute, let me see if you're able to see this or not. No, you're not able to see this, right? Okay, so basically it's DNF block, it's getting blurred. So basically it's DNF block in just one page, right? So when you are alone, you are more focused. You are more focused, right? So that means, can I say that P naught A or anything is greater than P? P naught is greater than P. Here the pressure will decrease, right? Earlier the pressure was more. He was sitting alone. But now, because he was sitting along with the friend, that is solute, now he will start getting distracted, right? Right? So that is why the pressure will decrease. Okay? But in reality, in chemistry, what will happen? Because of the interaction of this solute and this solvent, right? Less vapor pressure will be there, right? Less vapor pressure by the solvent will be there. That means initially it was more, fine, after adding solute it is less. That means, can I say that? And moreover, one more thing, wherever we are talking, we are adding non-volatile solute. Non-volatile solute. Now he is that friend who is not interested in studying. Non-volatile, non-focused person. Non-focused person is your student, is your friend. Now that friend will come enter your life. He will also decrease your focus, right? So that is why when you are adding non-volatile solute, your pressure is going to decrease. This is what we call lowering in vapor pressure. This is what we call lowering in vapor pressure, because the vapor pressure has decreased. So if the vapor pressure has decreased, can I say what amount vapor pressure? P naught is the initial big thing. This is the final, right? So this has decreased. This will be your lowering in vapor pressure, right? That is your lowering in vapor pressure, right? So let us write here lowering in vapor pressure. This is called your lowering in vapor pressure, right? Lowering in vapor pressure, right? Now tell me one thing. Can I write this delta P, that means the change in pressure, P naught minus P, that is lowering in vapor pressure. Can I write this P as P naught minus P naught mole fraction? Right? P naught mole fraction. Can I write this thing here? Right? Can I write this thing here? Right? So here we are talking about solvent. Right? So here, this is your P naught. If I want to calculate this is my lowering in vapor pressure. If I am saying that, ma'am, we want to calculate the relative lowering. So whenever there is relative term, what does that mean? Relative means in comparison to something. So when you are comparing something with something, relatives always compares us with something, right? So you can remember this, relative means comparison, right? Relatives are always comparing us with something, right? So they are not talking about lowering in vapor pressure. They are talking about relative lowering in vapor pressure. That means this lowering in vapor pressure divided by the initial term, what it was. Initial was P naught. This is called the lowering in vapor pressure. So it will be, this will be equals to P naught minus P by P naught, that will be equals to wait a minute, P minus P naught is equals to P minus P naught minus P, wait a minute. Yeah, instead of this, we'll just use this thing, right? Okay, I'll start deriving it before here only. From here only, I'll derive it, right? So from here, can I take the P naught as common and this will be 1 minus mole fraction? Now tell me one thing, ma'am, you have not mentioned anything here. If I mention everything here, what I will do? If I talk about, if I'm talking here, I'm representing 2 as the solute and I'm representing 1 as the solvent. 1 as the solvent. 2 as the solute, 1 as the solvent. So when I was talking here, I was not talking about the solute. I was talking about the solvent. I was saying you are the solvent, you are sitting there in your room and someone is coming in your room, right? They are decreasing your focus, right? So basically, I am talking about solvent. Solvent is represented by 1. Here it is 1. So this is P naught 1, P1, right? So this will be 1, this will be 1. This will also be 1, this will be 1, this will be 1, right? So after this, can I write this P naught minus P equals to P naught minus P naught, this is 1, 1, 1. This is Chi1. Take P1 naught common, this will be 1 minus Chi1, right? This will be P1 naught minus P, right? Then after that, can I say, if I take this here, this will be P1 naught minus P1 divided by P1 naught. 1 means we are talking about solvent. And here it is equals to 1 minus Chi1. We know that Chi1 plus Chi2 is equals to 1. So 1 minus Chi1 is equals to Chi2. So can I say here it is Chi2, right? So from this side, this term is called the relative lowering in vapor pressure. Relative lowering in vapor pressure. So basically that means here you have P naught minus P, that is lowering. When you are comparing it with something, that is your relative lowering, right? So for 2-3 questions they can ask you from here. First is, relative lowering in vapor pressure is a colligative property. Lowering in vapor pressure is not a colligative property. This is not a colligative property. P naught minus P is not dependent on the number of moles of solute. Rather, P naught minus P divided by P naught is dependent on the number of moles of solute. So this is not a colligative property. This is a colligative property, right? Relative lowering is a colligative property, right? Okay. First question, this they can ask you. Next is, they can ask you that if we want to write it further, so this will be P minus P naught equals to mole fraction of 2. Why I have not mentioned here 1, 1, 1? Because usually we talk about solvent only. So in some books you will see that 1 is not mentioned here, right? 1 means solvent only. You can mention, or you can, if you don't mention also, that doesn't matter, right? Because we are talking about the vapor pressure of solvent only, because solute is a non-volatile thing. So solute will have 0 vapor pressure. There is no, because solute is non-volatile, it will not form any vapor. So if there is no vapor, so what we are talking about vapor pressure? No vapors means no vapor pressure, right? So here we have, this is basically, there is, solute is non-volatile. That is why if you write 1, perfect. Even if you don't write 1, that is also okay. But here you have to mention 2, because mole fraction is of solute as well, solvent as well, right? So here we know that this will be equals to N2 divided by N1 plus N2, right? P naught minus P divided by P naught, right? If we say solute is very, very less, right? So in that case, can I say N1 plus N2 is approximately equals to N1 only? Because this is very small. Solute is very small. So we can just ignore that in the summation. You will say, ma'am, can I ignore here also? Array, if it is in the summation, then you can ignore it. For example, there is 0.0003. You cannot ignore this term if it is sitting alone. But if it is 20 plus 0.00003, then you can ignore this term, right? So that is why we are ignoring this term here. It will be P naught minus P divided by P naught equals to N2 by N1. You can say this is W2 by M2 multiplied by W1 multiplied by M1, where capital M is the molar mass, W is the weight, right? And this will become your final formula, right? And in the question also, if they ask you relative lowering in vapor pressure, then apply this formula. If they ask you lowering in vapor pressure, then you have to calculate P naught minus P only, right? Okay. So, very slight difference between these two things, right? As you can see, this is directly proportional to the mole fraction of solute. That is why it is a colligative property, hence proved, right? Okay. Okay, students, understood? Relative lowering in vapor pressure, right? Simple. Wait a minute. Now, next colligative property, second colligative property is your elevation in boiling point. If you talk about elevation in boiling point, let us talk about vapor pressure first, right? Okay, before that, tell me what exactly is boiling point. If you talk about boiling point, what do you mean by boiling point? What do you mean by boiling point? If I say boiling point of water is 100 degrees Celsius, what do you mean by the definition of boiling point? You should understand, then only you will be able to think that why there is elevation of boiling point, why there is no depression of boiling point, right? Why boiling point is not decreasing. There should be some reason behind that, right? So basically boiling point means that what exactly will happen here? Boiling point means when your vapor pressure of that liquid become equal to the atmospheric pressure. Atmospheric pressure. Okay, it becomes equal to the atmospheric pressure, right? So now, what you saw here. So this is your atmospheric pressure, right? This is the atmospheric, the pressure of this atmosphere, right? This is the vapor pressure of pure solvent, right? Now, I told you one thing, that vapor pressure of pure liquid is more than vapor pressure of solution. When you add the non-volatile solvent, then vapor pressure decreases, right? From these two things, we are going to see why there is elevation. Here I am saying this is your atmospheric pressure, this is fixed. No one can change it. Our atmosphere has a specific pressure, we cannot change it, right? Human cannot change the atmospheric pressure. We can have a beaker where we can change the pressure of that beaker, but atmosphere pressure we can't change, right? So it is fixed, right? That is in the hands of nature. So that is there, atmospheric pressure. This is my vapor pressure of pure liquid, right? This is my vapor pressure of pure liquid. Earlier I have to, firstly, for example, this is your NEET cutoff. This is you currently. You have to do this much hard work to get into your dream college. This much hard work to get into your dream college, is it? Now, for example, your vapor pressure, someone bad has come in your life, right? Someone who is distracting you, right? So what will happen? Your focus will further decrease. Vapor pressure further decreases. As we know, on adding solute, the vapor pressure of solution decreases, right? So you can understand this by that you were sitting alone and this is your target. You think that you are able to achieve the target. This is the jump that you need. Now someone came in your life and they are distracting you. Your vapor pressure decreases, right? Relative lowering in vapor pressure. Now the jump is more. Now you have to jump more, right? That means your boiling point has increased. You have to have more jump. You have to do more hard work. Because you have wasted 2-3 months, right? So same thing is happening with them. Vapor pressure of liquid decreases on adding non-volatile solute. That is the reason there is elevation in boiling point. Before we say boiling point is TB naught, and after adding this, we say boiling point is this. And the jump is more, that is why TB naught is less than TB. That is why delta TB is regarded as TB minus TB naught. TB minus TB naught, right? That is called elevation in boiling point, right? Temperature at which vapor pressure of liquid becomes equal to external atmospheric pressure is called boiling point. On addition of non-volatile solute, the vapor pressure of solvent decreases. Therefore, boil of the solution containing non-volatile solute required for it will be higher. That is, TB is higher than TB naught. There is elevation in the boiling point. That is the reason, that is the only reason we say this is the graph that we can draw. Graph is directly from your NCERT and a very, very beautiful graph. A very, very beautiful graph. So now here what they are saying, that this is your vapor pressure and this is your temperature, right? Now he is saying that this pressure, right, this is the atmospheric pressure. This is your NEET score that you need to have. This is your NEET score that you need to have, okay? This is the NEET score that you need to have, right? I am writing it here. This is the NEET score that you need to have, right? Okay, this is the NEET score that you need to have. Now, what will happen here? What will happen here? Earlier, what happened? There was simple solvent. This is the simple solvent, right? Wherever this solvent will touch the atmospheric pressure, that is your boiling point. The graph was drawn and it was found out to be that this solvent touches the atmospheric pressure. That means the vapor pressure of this solvent is equal to the atmospheric pressure at this particular temperature. And this temperature is called the TB naught. This temperature is called the TB naught. Now we are saying, graph to I have just started. I have just started the graph. So this is basically your vapor pressure. This is your temperature, right? So a graph was drawn on variating the temperature, what is happening. On variating the pressure, what is happening. When we drew the graph of a solvent, when there is no solute added, in that case, this is the graph that they observed. This is the graph that they observed. This is the graph that they observed. Now what they observed, that at this point where the vapor pressure of this solvent will touch the atmospheric pressure, that is your TB naught, boiling point. What is boiling point? When vapor pressure of liquid touches the, is equal to the, when vapor pressure of the liquid is equal to the atmospheric pressure, that is the boiling point, right? Now we are saying, we have added the solute. Now vapor pressure has decreased. Earlier it was this side, now it is this, because vapor pressure has decreased, right? When the vapor pressure decreases, the point at which solution, the vapor pressure of the solution will touch the atmospheric pressure, that is this, and that is your TB. We can easily see TB naught is less than TB, right? And this difference is called the elevation in boiling point, that is delta TB. Okay, this difference is called the delta TB. Now, let us see what exactly is the formula of delta TB. I am writing it here. What is the formula of delta TB? It is delta TB equals to Kb into molality. Molality means what? Number of moles of solute. Molality means number of moles of solute divided by weight of solvent in kilograms. If you want to write out weight of solvent in grams, then you have to multiply this by 1000, right? This is delta TB only, right? Delta TB equals to Kb. I'll tell you what is Kb, right? N2 is weight of solvent divided by, number of moles is weight divided by molar mass. M2, this is W1 and this is 1000. Now, if you want to write it, what is delta TB? Delta TB is TB minus TB naught. right? This is the whole formula from where the questions are asked, and it is a very, very important formula, right? Very, very important formula. From here, they can ask you anything. They can ask you TB, right? They can ask you W2. Usually they ask W2, M2 or TB. This is the hot questions from this chapter that they will ask you. They will give you everything. They will ask you weight of the solvent. What is the weight of the solvent? Or they can ask you what is the molar mass of the solvent. Or they can ask you, they will give you everything. They will ask you to which extent the boiling point increased. What is the final boiling point after adding the solute, right? Now tell me one thing. If they ask you, there are two things, okay? There are two things, two terms. You have to tell me that is basically English only, right? But I'll see how good is your English. Okay, let me see how good is your English. Acha. There are two terms. Let me write here. One is boiling point is increased by. One is boiling point is increased to. Tell me in which they are asking what thing. If they are asking this, basically pronunciation I am teaching you. English class guys, English class guys. Pronunciation I am teaching you now. Now tell me, boiling point is increased by and increased to. What is the difference? If we say boiling point is increased by, that means to this extent the boiling point has been increased. That means earlier you are at this position, but you are now at this position. This is the difference that you have, right? It is increased by this much amount, right? So that is your delta TB. That means here they are asking you delta TB. But if they say boiling point is increased to, that means initially you were at this position, now you are at this position. So you'll tell what is this position. They are asking you the final position. That means they are asking you the value of TB, not a delta TB. This is the biggest problem that students do. Otherwise, in the options also you can see if the value is very small, that is your delta TB. Right? If value is large in terms of 100 Kelvin, 200 Kelvin, that means they are talking about TB. Right? Okay? Okay. Now, next important thing here is, this so we have done, boiling point increase to also we have done. Now, one more thing regarding this is this TB naught. Ma'am, what will be the value of TB naught? Now, usually you will be given water as the solvent, right? If they have not given water as the solvent, they will mention you what was the initial boiling point of the solvent, right? But usually if you see aqueous solution and this and that, that means they have given you water as the solvent, right? So if water as a solvent is given to you, that means 100 degrees Celsius you will take, right? Okay, 100 degrees Celsius will be your TB naught. But just see that if water is given or anything else is given. Okay, if something else is given to you, then in the question itself, they will mention what is the boiling point of the solvent, right? Now, third important thing here is, should we take it in degrees Celsius or Kelvin? Anybody in the chat box? Should you take it in? Should temperature be in degrees Celsius or Kelvin? What should we take? Degree Celsius or Kelvin? In thermodynamics, I taught you temperature in Kelvin, right? Here, what should happen? Degree Celsius or Kelvin? Any idea about it? Any idea? Okay. Now, it doesn't matter. You can take it in degree Celsius, you can take it in Kelvin, it doesn't matter at all. Why this doesn't matter? Yes, it doesn't matter. Reason is, firstly, you will see the options. If the options is in Kelvin, then you will substitute the value in Kelvin. If the option is in degree Celsius, then you will substitute the value in degree Celsius, right? For example, they are asking you, this is delta TB, this is TB minus TB naught. If they are asking you the value of delta TB and the option is in Kelvin, then you will take this also in Kelvin, this also in Kelvin, right? If they are asking you delta TB, you can also take this in degree Celsius, this in degree Celsius. Answer is same. Answer will be same. How? If I talk about 4 degrees Celsius minus 2 degrees Celsius, or if I talk about 273, 4, 5, 6, 7, 277 Kelvin minus 275 Kelvin, right? In Kelvin, the answer will be 277, 273. Here also the difference is 2 degrees Celsius. Here also the difference is 2 Kelvin. So delta TB is going to be same only. Doesn't matter. Delta TB will be same. It doesn't matter, right? Okay. Now, yes, Mr. Kelvin, Mr. Celsius. Now, if they are asking you TB, if they are asking you the value of TB, in that case you have to see. If the option is in Kelvin, then you will put this also in Kelvin. That means you will put it as 373 Kelvin, right? If the option is in degree Celsius, then you will put it in degree Celsius, that is 100 degrees Celsius, right? Okay, so delta TB doesn't matter because difference is going to be same only. For TB, you have to see the options in what thing they have given the answer, right? Okay, understood? Yes, students, understood? Okay, chalo. Now, next is, what is this KB, ma'am? What is this KB, ma'am? This KB is basically your elliptioscopic constant, or this is your molar elevation constant, and this will be given to you in the question, right? That will be provided to you in the question itself, so you need to worry about that thing, right? But if you talk about the formula, that is Rm1 multiplied by TB square 1000 into delta H of vaporization. Nobody asked this thing, right? They will not ask you this formula. Just go through it once, right? Just go through it once. That's it, right? Now, next third colligative property is depression and freezing point. If you are asking about depression and freezing point, for that you have to understand what exactly is freezing point. What is freezing point? Then only you will be able to understand why there is depression in freezing point, why there is no elevation in freezing point, right? Depression in freezing point, reason. Now, basically freezing point means your vapor pressure of that liquid should be equal to vapor pressure of that liquid in solid state. If I am saying that for that liquid, if it wants to convert into solid state, in solid state it has this kind of vapor pressure, right? Let's imagine that, okay? So see one thing. The vapor pressure of liquid is equals to vapor pressure in solid state, right? So the vapor pressure of solid, because something has freeze. Now first you tell me one thing. In our atmosphere the pressure is more, or the solid has more pressure? Which has more pressure? Like in which the vapor pressure will be more? Vapor pressure, I am talking about pressure, vapor pressure. Which will form more vapors? In air more vapor exists, or in a solid thing? For example, I talk about ice. How many vapors can exist in ice? Which has more vapor pressure? Atmosphere or solid? Any solid. I am talking about ice here. Definitely a solid. Students, please ask. Please answer. Definitely. Atmosphere will have more vapors. It will have more vapor pressure as compared to a solid, right? As compared to a solid, students. Yes, be active, right? Don't sit there and sleep, right? Okay. So now atmosphere, and this is solid. Atmospheric vapor pressure is definitely more because of more gases, right? But in solid state ice, how it will have vapors, vapor pressure? So definitely atmosphere has more vapor pressure as compared to solid. So it is so more that if I want to write the vapor pressure of solid, it is here, right? It is here. This is the vapor pressure of the solvent. Understood? This is the vapor pressure of the pure solvent. Right? This is the vapor pressure of the pure solvent. I'll be writing it here. Right? For example, this is the vapor pressure of pure solvent. And this is the vapor pressure of solid. Now tell me, what is a freezing point? Freezing point is when this vapor pressure of solvent will match this vapor pressure of solid. That is defined as the freezing point. That means this is the jump that it has to take, right? And that jump we will call as T naught F. F means pure solvent freezing point. Now I have added non-volatile solute. Now I know that whenever I am adding non-volatile solute, there is lowering in vapor pressure, right? So that means vapor pressure of solution will be somewhat here. This is vapor pressure of solution. Now this is the jump that it has to do. That is your TF. That is your TF. So you can easily see earlier this was the jump. Now this is the jump. That means the jump is less. That means you can see that TF naught is greater than TF because there is decrease in freezing point. That is why it is called depression in freezing point. Right? That is why it is called depression in freezing point. Yes, Tanuja, Roshni, Mardai, Newton, Sukanya. Yes, yes. Putswami. Yes. Now, I hope so this is clear to you. If you want me to write same for boiling point, let's write it here. Simple thing, it's very simple thing. Okay, so I'll write it here. So basically what we are saying that earlier you had, this is your atmospheric pressure. Atmospheric pressure is definitely more than vapor pressure of solid, no. So this is your vapor pressure of solvent. And earlier the jump is called T naught B. But now because there is lowering in vapor pressure after adding solute, this will become your vapor pressure of solution. Now the jump will be this one. That is your TB. Here you can see that TB naught is less than TB. Right? That is why here you have elevation. Right? Okay. Acha, tell me one thing with freezing. Let us see the graph of the depression in freezing point. The graph is little complicated, right? But I'll explain you. Wait a minute. I think from this you'll be able to understand this more easily. Because just keep this in your mind. Just keep this thing in your mind. If you have this thing in your mind, you will be able to understand this more clearly, right? Now, I am saying that this is the frozen, wait a minute, yes, this is your vapor pressure of the solid, right? This is your vapor pressure of the solid, okay? Wait a minute. This is a frozen solvent, no? This is a frozen solvent, wait, yes. This is the vapor pressure of frozen solvent. This is the vapor pressure of frozen solvent, right? This is the vapor pressure of frozen solvent. Now, if I talk about pure solvent, when we have not added anything, in that case, it will strike the vapor pressure of frozen solvent at this point. At this point, it will strike the vapor pressure of frozen solvent. And this will become your TF naught. And this will become your TF naught. But if you talk about the, when you have added solute, the vapor pressure of liquid will decrease, right? Now it will touch the vapor pressure of solvent at this point. At this point, it will touch the vapor pressure of solvent, frozen solvent, and this will become your TF. This is your TF naught. Now, as you can see, TF naught is more as compared to TF. TF naught is more as compared to TF. So, there is freezing in, there is depression in freezing point, right? So that we can say that there is depression in the freezing point. Now, tell me, is this graph clear to everybody? Is this graph clear to everybody? Yes, very beautiful, very beautiful. Is that graph clear to everybody? Now what we will start doing, everybody? Yes. Now let us see the formula of depression in freezing point. That is delta TF equals to Kf into molality. This Kf is called a constant, that is called molar freezing point constant, or you can say cryoscopic constant, right? We will, I'll tell you about that constant as well. M is nothing but molality. So in the same way, we will put it as W2 by M2 multiplied by W1 into 1000. That is your molality. What is this? TF minus TF naught. Because there is depression. No. It will be TF naught minus TF. Basically, it is larger minus smaller. No. So, which is the larger value? Larger value is TF naught because there is depression. We know that TF naught is greater than TF. That is why larger minus smaller. Right? So, always you will do. But in elevation, you had TB is greater than TB naught. That is why delta TB was TB minus TB naught. Here it is TF naught minus TF. Right? So, that is the difference. Right? Okay. Now what to do? Everything else is going to be same. The same way you will solve this. The same way things will happen. Right? Now, what is this Kf? Kf is defined as the cryoscopic constant. Right? Molar depression constant, freezing point depression constant, cryoscopic constant. Right? So, the units are Kelvin kilogram per mole. Right? Okay. And the formula is R into M1 TF. Instead of TB, there is TF. Instead of delta H of vaporization, there is delta H of fusion. That's the only difference. Right? Again, nobody is going to ask you the value of Kf here. Right? But still go through this. They will not ask you numerical based on this. But still go through the formula. That's it. Okay? Now, tell me one thing, the application of this thing. The application is very, very important. Okay? One application I will tell you. For example, you can do this in your home as well, right? For example, you have a simple solvent, that is water, right? And in one glass, you take simple water. In next glass, you take water and dissolve some NaCl into it, right? Dissolve some NaCl into it, sodium chloride, solute into it. Solute is non-volatile, right? So now what will happen? After 3-4 hours, what you will see that your simple solvent, water, has been freezed to more extent as compared to the one which has solute dissolved into it. Why? Because freezing point decreased, right? For example, 3 degree was the freezing point of that water, right? You have decreased the freezing point to 1 degree Celsius. Right? You have temperature at 2 degrees Celsius. So at 2 degrees, this will freeze, but this will not freeze. Right? Why? Because the freezing point is only 1 degree. So how come at 2 degrees it will start freezing? Right? So that is the benefit. Right? I have started organic chemistry way back. Right? Okay. Now, let us see. Even in some of the colder countries, what they do now, sometimes what happens that the ice is too much, the snow is too much outside, right? You go outside and your hair also, even if you have just 2-3 droplets of water, it will start freezing, right? To that much extent, when the temperature is minus 10 degrees Celsius, minus 7 degrees Celsius, what they do, right? Yes, the PYQs are included here, right? What they do, they add some salt into it, right? So that the water has low freezing point now, so that the water cannot freeze, right? So that is the useful thing about this depression and freezing point. Second thing is anti-freeze solution. In your, whenever we are going on some Leh Ladakh trip somewhere in mountains we are going, then what we do, in petrol we mix ethylene glycol. When we mix ethylene glycol in petrol, what exactly happens? Anti-freeze, that means it will lower down the freezing point. That is how our petrol will not freeze, right? This is the same thing that they have written here, right? To remove snow on the roads at low temperature, common salt is spread on the roads. The freezing point of water is depressed to avoid the formation of the ice. So that was the useful thing of depression in freezing point. Now let us see some questions based on this. Yes, very good. Okay. Let us see some questions. Here it is. At 100 degrees Celsius, the vapor pressure of solution is 6.5 gram of the solute. That means this is the weight of the solute. Weight of the solute is given by 2. So it is your W2. And here it is 100 gram of solvent, that is your W1. Right? At this much pressure is given to at 100 degrees Celsius, the vapor pressure of solution is this. That means solution means they are talking about partial pressure, right? If Kb is given to be this, the boiling point of this solution, Kb is given to you, right? They are asking you the boiling point of this solution. Okay. So I think pressure is ऐसे they have given you unnecessarily, they have given you the pressure, right? Because otherwise what you want to calculate the boiling point of the solution, that means TB. What is TB naught? Because it is in degrees Celsius, I will take TB naught. We will apply this formula is equals to Kb into molality. Molality is W2 by M2 multiplied by W1 multiplied by 100. Multiplied by 1000, right? Okay. Now, 100 degree vapor pressure of this much of a solute in this, gram water is this, and if Kb is this, the boiling point, it is the pressure of the vapor pressure of the solution of this much of solute, right? Okay. Now, let us see here what they are asking you. This is your TB. TB minus what is TB naught? TB naught is 100 degrees Celsius. What is Kb? That is given to be 0.52, right? And here it is W2, right? So this is given to be your, we can calculate actually which thing from here. We don't have the value of M2 here, right? We don't have the value of M2 here. So basically this was given to calculate the value of M2. Value of M2. What is the solute here, right? Okay, like ice cream bar, down will be little salty. Yes, true. Okay, so we will firstly calculate the value of M2 because W1 to we have, W2 is what, that is 6.5, right? This is 1000 divided by M2 is not given to us, right? Then you have what is W1, that is given to be 100, right? That is given to be 100. So we will firstly calculate the value of M2 here, right? So as you can see here, from this side we will firstly calculate the value of M2. Wait a minute. From this side we will firstly calculate the value of M2. Let me show you how. Everything else is the same only, right? Now, for M2, vapor pressure is given to us, that is P, right? Okay. P is given to us. Now we know that P is equals to, if you talk about all the other things here, P is equals to P naught multiplied by mole fraction, right? Now, if you talk about, you can directly calculate the value of that, no? So, your relative lowering in vapor pressure is what? P naught minus P divided by P naught equals to mole fraction of 2. What is this? This is W2 by M2 multiplied by W1 into M1, right? Here we know that W2 is what? Your weight of solute, that was given to be 6.5. This is 6.5. M1 is what? Solvent. Solvent is water. Water is nothing but the weight is 80, right? W1 was given to you, that was your 100 grams, right? Okay. Now, M2 is given, M2 you have to calculate from here. What is P naught? P naught is the atmospheric pressure. You can, not atmospheric, the general pressure. If nothing is given to you, you will take it as 760, right? Okay, that is the standard pressure, right? Minus what is the PS that is given, vapor pressure that is given is, not vapor pressure, the partial pressure is given to be 732. Minus 732 divided by 760. From here you will calculate the value of M2. Here they have calculated the value of M2 as M2. They have not calculated the value of M2. Basically they have just put the value of this thing here. They have just put the value of this whole thing right into that, right? So you can do also one more thing you can do. Instead of doing this thing, you can do also one more thing. You can put it as this is W2 by M2 multiplied by W1. W2 by M2 into W1. This is multiplied by M1. What is M1? That is 18. Right? You can take 18 over here. You can take 18 over here. So that will become 1 by 18. Right? So you can calculate this value W2 by M2 into W1. You can put this value over here. You can put this value over here. Right? You can put this value of this whole thing over here. I am assuming that this turns out to be X. 760 minus this, I am assuming that this is turning out to be, here they are calculating different ways of calculating this, right? I am calculating W2 by M2 into W1. So this is W2 by M2 into W1. This will turn out to be, this is 760 minus, this is 28 divided by 760 multiplied by 1 by 18, right? So I'll just put this value 28 into W2 by M2 into this, W2 by M2 into W1. This is 28 by 18 into 760, right? Okay, 760. Now you can calculate the value here, right? And here it is 100 degree, right? Students, that is going side by side. Yeah, organic chemistry, I am going to do that side by side. Organic and physical are going simultaneously, right? Okay, so you can just put this value. Baki is totally your choice. If you want to calculate M2 from here, then put the value of M2 there. That is also fine. If you want to simply calculate W2 by M2 into W1, because the same term will be used up over here, then you can use the same thing, right? Okay, that is totally your choice. And here, TB will be equals to 101 degrees Celsius, right? So answer will be C is the correct answer. Baki, it's your choice what you want to do, right? But here this was an important question because two things are involved here, two properties they have asked you simultaneously, right? Next question is, there is next property, fourth property, that is your osmosis. Now basically what is osmosis? Osmosis, diffusion, what are these things? Basically it is the movement. If you talk about ma'am osmosis, how you can define osmosis? There are 2-3 ways of defining osmosis. So osmosis, you can say that basically it is the 2-3 ways you can tell. Firstly, you can say that it is a movement of pure solvent, pure solution to impure solution, or you can say impure, wait a minute, yes. Pure solvent, okay, I'll just firstly write it in the form of solvent. In the form of solvent, then we will write it in the form of solute, right? So basically if you talk about in the form of solvent, it is from high concentration. It is from high concentration to low concentration, right? Just remember this statement, other statements, so you can derive from this statement only. If high concentration to, for example, this is a solution which has more concentration, this is a solution B which has less concentration. of solvent. So if solvent is moving from high concentration to low concentration, it has more solvent, right? For example, okay, let us take one more example here, very simple. See, this is your A and B, this is your A and this is B. How it is used? I am saying that this is my solution, this is my solution, this is my pure solvent. Okay, this is my solution, this is my pure solvent. Now, from this statement only we will understand everything. I am saying that osmosis is a movement from high concentration to low concentration. And this movement, I know that concentration high, which will have high concentration and low concentration, which will have high concentration, which will have high concentration. If you have pure water, definitely it is going to have more concentration, keeping the volume as same. Keeping the volume, for example, I have this beaker, right? It is only water. Now, keeping the volume as same, if I add some sand into it, if I add some NaCl, if I add 5 spoon NaCl into it, I know that NaCl is going to take up the space of this solvent, right? So, some solvent I will take out also, right? So, with the same volume in the solution, the concentration of solvent will be less. So, that means here the concentration of solvent is less. Less solvent, and here the concentration of solvent is high. High solvent. So that means in osmosis, it is going to move from A to B, right? That is high concentration of solvent to low concentration of solvent, right? If you talk about solute, solute also it will move the same way only, right? It's just that in this solvent you have no solute, in this you have no solute, right? So that is why the concentration of solute is, wait a minute, this is less solvent. Ulta, wait a minute, yes, solvent has more concentration. In solvent, the concentration of solvent will be more, no? So more solvent, and here it will be less solvent. And here it will be less solvent, right? Okay, if you talk about the solute is definitely more in which thing? Solvent will have no solute, right? So that means less solute concentration, less solute, and here you will have more solute because you have added solute into it. So here it will have more solute, So here we will write, it is from low concentration to high concentration. Because the thing is same. The final statement is same only. That it is moving from A to B or B to A. More solvent to less solvent. That means B to A it is moving. So whether you say solvent is moving from high concentration to low, or you say solute is moving from low concentration to high, that is the same thing only. It's just that the way of saying things is different, right? I can also say that in one more term, that is in terms of the solutions. It is moving from pure solvent to solution. Right? It is moving from pure solvent to solution. That is also called your osmosis. So these are the three definitions of osmosis, right? Three definitions of osmosis. And in osmosis, when it is moving, only what will happen? You will have a semi-permeable membrane over here, right? So basically, this is the full diagram over here, right? This is your solution, this is your solvent, right? And this is the semi-permeable membrane. The excess pressure. Now, students, what we are talking about? We are talking about osmotic pressure. We know that the movement of solvent particles from high concentration to low concentration, that means this is your osmosis. From this compartment to this compartment is called the osmosis, right? If you want to stop the osmosis, right, the excess of pressure that must be applied in the solution to prevent the passage of solvent through semi-permeable membrane. so that the solvent cannot pass through this semi-permeable membrane. The pressure that you will apply here is called osmotic pressure, that is defined by pi is equals to CRT. This C is called the molarity concentration, right? That is why pi is equals to number of moles of solute divided by volume of solution in liters into RT. This will become your final formula of colligative property, right? Next is, if we are saying, this is the formula only, right? If we are saying reverse osmosis, now first condition was when this A was moving to this, for example, I am naming this compartment as, this compartment is A, this compartment is my B compartment. Now, when nothing we are doing, osmosis, because of osmosis, the solvent particles will move from high concentration to low concentration, right? If I am applying the external pressure to that extent so that I can stop this osmosis, that is called osmotic pressure. If I have exceeded that pressure, if I am applying more pressure as compared to pi, that means if pressure exceeds the osmotic pressure, that is called reverse osmosis. That is called reverse osmosis, and this system is used in your RO, right? In your RO, from where we drink the water, right? This reverse osmosis system is used. Now let us see how this system is used, right? So basically, I'm just giving you one example. That for example, you have you have a pure water, and this is your impure water. This is your impure water, right? So what will happen here? What will happen here? What will happen here? See, during osmosis, what should happen? Pure water will have more solvent, so it should move from this side to this side. Water should move from this side, right? This side to this side, that is osmosis. If I am applying external pressure, then I will stop the osmosis. If I am applying external pressure more than the osmotic pressure, then it will do the reverse thing. That is, it will start going in the opposite direction, and your solvent particles will start moving from low concentration to high concentration. That means your water will get out of the impurities and you will get pure water in the end, right? You will get the pure water in the end. So that is why they are saying the phenomena in which direction of osmosis can be reversed if a pressure larger than the osmotic pressure is applied, that is called reverse osmosis. It is used in desalination of seawater, right? In seawater you have NaCl, how to take out impurities with the help of a reverse osmosis system, right? Okay. Yes, very good, very good, very good. So now that is also very important. Now next thing is your isotonic, hypertonic solutions. What is an isotonic solution? Isotonic solution is which has same osmotic pressure. For example, pi 1 is equals to pi 2. Now this has same osmotic pressure. It is called the isotonic solution. If I say hypertonic and hypotonic, if I am saying pi 1 is greater than pi 2, in that case the one which has more osmotic pressure is called your hypertonic. The one which has less osmotic pressure is called your hypotonic. This is called hypotonic, that is called hypertonic, right? What is hypertonic? Which has more osmotic pressure. Hyper means more energy, very hyper, right? So which has more osmotic pressure is hypertonic, which has less osmotic pressure is hypotonic, right? So from this side only, very, very beautiful questions they ask you, conceptual question that is regarding the blood cell. So now exactly, you all know that in our body we need a specific things, right? So whenever we have intravenous injections, right, inside the veins, right, we need a proper concentration, and that concentration is 0.9% NaCl. The injections that we should use should have 0.9% NaCl solution. Now if it is more or less than that, then dangerous things can happen. So now what can happen if it is more? What can happen if it is less, right? So basically, for example, I am saying hypertonic solution, right? In hypertonic, I am saying it is more than 0.9%. 0.9%. Here I am saying hypertonic means less than 0.9%, right? Now I'll tell you what exactly, I'll tell you about hypertonic solution, okay? About hypertonic solution. Hypertonic. We are saying it is more than 0.9. More than 0.9. Basically, this is the concentration, right? Concentration is solute by solvent, right? Right? Concentration is solute by solvent. So, can I say that here, if the concentration is more than 0.9%, that means the concentration of solute has increased. Because concentration of solute is more, na? That means concentration of solute has increased. If your concentration is more than 0.9, that means concentration of solute, because what we actually check, we check the concentration of solute only. That means the concentration of solute has increased. If solute has increased, that means solvent will decrease. They are opposite. Concentration of solvent will decrease. Now this is in your injection. This is in your injection. This is in your injection, right? So that means, can I say in hypertonic solution, the injection that we are giving, the injection, I am giving you a very weird injection, right? In this injection, you have more or less solvent. What we have written is less, right? So you have less solvent, less solvent. In blood, you have proper 0.9%, that means you have more solvent. That means you have more solvent in blood cells. Now tell me, in osmosis, what will happen? Thank you so much, SRGM, thank you so much, right? Ma'am, please, hypertonic. Yes, that is only what I am explaining you, right? So now, more solvent to less solvent, or less solvent to more solvent. Osmosis is what? Osmosis is from more solvent to less solvent. That means it will go from more to less. That means the water will start coming out of the blood cell. And when something is coming out, that means your blood cell will shrink, because it is dehydration is occurring, right? That means it is going to shrink here, right? That means it is going to shrink, right? That means it is going to shrink. Or you can just understand this with a very simple fact. Hyper means someone who is very angry, right? Hyper means, why you are getting so hyper? That means someone who is very angry. Someone who is very angry is always shrinked, always like, right? I don't want to talk to you. Someone who is hypo, very happy, right? They're always like, smiling, giving positive vibes. So they're always swelling, right? Very happy, right? So they are very happy in life, right? So they are swelling, right? So this is shrinking, this is swelling. Now we can also talk about why this swells. So this is also a very simple fact here. For hypertonic also, this is the same fact that we will discuss, right? Same thing will happen here. Same thing will happen here in hypertonic, right? Same thing. If you talk about hypertonic also, same thing will happen. In hypertonic, what can happen? In hypotonic, what can happen? We are saying in hypertonic solutions, the concentration is less than 0.9%. That means concentration of solute decreases, right? That means concentration of solvent increases, right? That means this will have more concentration, right? Your injection will have more solvent, and in comparison to that, because it is more, right? Solvent is more. In comparison to that, it will have less solvent. That is why it is going to move from more to less. That means this side. That is why we are adding the water into the cell, right? That is why cell is getting swelled, right? It will swell. Okay? Understood? Introvert and extrovert. Yeah. Introvert and extrovert only. Okay, understood this thing. So it's a very, very beautiful concept regarding our body. So that is based on osmosis. It's not like if you give, oh my God, to my patient, I want them to be happy, I will give them less than 0.9 concentration so that they can swell. No, right? Our body needs 0.9% concentration only, right? That is a specific thing. If it fluctuates, that will harm our body, right? Okay. Now, next is some questions here. The freezing point constant of benzene is 5.12 Kelvin kilogram per mole. The freezing point depression of solution of molality this containing non-electrolyte in benzene is, okay. Depression constant is given to you. For solution of molality is given to you, right? Solute is given to be molality. If molality is simply given to you, Kf is given to be 5.12 kilocalvin, right? It is kilograms. So convert that into grams only. Okay. So it is Kf, and here it is given to be molality is given to you, right? Kf is given to you. This is molality. This is also given to you. They are asking you the freezing point depression constant. They are asking you the freezing point depression for the solution. Freezing point depression, that means how much depression is there. They are asking you delta TF. What you have to see, you just have to see the units here, right? Everything else is given to you, right? So very simple. This is Kf in terms of, this is, wait a minute, yes. So now here just you have to see 5.12, that is Kf is given to you. Yeah, that was in same units only. Molality is given to you in M only, right? Just have to multiply this, you will get your answer, right? Next is, that was a very, very simple question. Now next is 200 milliliter of aqueous solution, 2011 question. 200 milliliters of aqueous solution of protein contains 1.26 gram. 200 milliliter solution, that means they are giving you the volume, right? Of aqueous solution of protein contains this much gram. Solution of a protein contains it's this much. That means W2 is given to you. The osmotic pressure of this solution is this. At this temperature is given, is found to be this. Osmotic pressure pi is also given. They are asking you the molar mass. So simple question it is, right? So basically it is pi is equals to CRT. What is C? That is number of moles of solute divided by volume in milliliter. If you want to write down the volume in milliliter, then you have to multiply it by 1000. Then it will be R into T. Now R is given to you in the question, right? R is given in the question, right? And what else you can write? Pi is equals to W2 by M2 multiplied by volume in milliliters multiplied by 1000 into R and T. Now everything is given to you. Pi is given to you in bars, so R is also in bars. R is given, temperature is given in Kelvin, right? W2 is given in 1.26. This you have to calculate. Volume is also given in milliliters. So this is the thing that you have to calculate. Put down all the values and you will be able to answer this, right? Okay. Okay. Okay, yes. Understood this or not? Yes? Okay, perfect. Now, next is abnormal molar mass and normal. Before that, let us do the Van't Hoff factor, right? I'll discuss this after we discuss Van't Hoff factor, right? Firstly, we will discuss Van't Hoff factor. So basically, what is Van't Hoff factor? The formulas that we discussed that were for non-electrolytes like urea, sucrose, glucose. But when we talk about electrolytes, they will dissociate. For example, NaCl. We think that we will have one molecule, but in reality, we will have two ions, that is Na positive and Cl negative. If you talk about acetic acid, you will think that you will have individual 1,1 molecules, but actually they will dimerize, they will associate because of hydrogen bonding, and you will have, instead of two molecules, it will dimerize and it will form one molecule only, right? So that means this is going to affect the colligative properties, because colligative properties are dependent on the number of particles of solute. Number of particles of solute are changing. We were thinking that there will be 100 molecules, but after association there are 50 molecules only because of dimerization in case of acetic acid. We were thinking about 100 particles of NaCl, but after dissociation we have 200 particles of NaCl, right? That means because of association and dissociation, the number of particles are changing. That is the reason the colligative property will fluctuate, it will change. So now let us see what is the change in the colligative properties. So all the colligative properties I am writing here, all the colligative properties, let me see if it is already mentioned here. It is already mentioned here, right? So all the colligative properties, whether it's relative lowering in vapor pressure, whether it's osmotic pressure, whether it's depression in freezing point or elevation in boiling point, they will have I as the multiplication factor, right? You will multiply Van't Hoff factor in all these properties, right? Then only you will get the correct value of the colligative property. Now let us see what is this Van't Hoff factor. This Van't Hoff factor is the number of particles, number of particles before, after association, dissociation, number of particles before association or dissociation, right? If you want to write it in the form of number of particles, if you want to write it in the form of colligative property, that is observed colligative property by normal colligative property, right? If you want to write it in the form of mass, this we will see in the end of this lecture, that is normal or actual molecular weight, actual weight divided by observed molecular mass that you will observe, right? Okay, now wait a minute, yes. Now, to understand this in more detail, let us understand the types of electrolytes. Basically, if you talk about, two things are there. First is, one is non-electrolyte. For non-electrolyte Van't Hoff factor, there is no Van't Hoff factor, that is equals to 1 only. Right? If you talk about non-electrolyte, then you talk about electrolytes. If anything like urea, glucose, they are mentioned, so your Van't Hoff factor is equals to 1 itself. There is no association, no dissociation. But if we are talking about electrolytes, there are two types of electrolytes. One is strong electrolyte, other is weak electrolyte. So in strong electrolyte, there is 100% dissociation. 100% dissociation, right? So that is why in this case, Van't Hoff factor is equals to number of particles dissociated, right? Simple, because alpha is equals to 1, But for weak electrolyte, there is alpha percentage of association and dissociation. Hence, you will have your Van't Hoff factor is not equals to n. Your Van't Hoff factor will not be equals to 1. You will have to see what is the value of alpha. For example, out of 100 molecules, how many molecules are getting dissociated? If only 50 molecules are getting dissociated, according to that, you will have the Van't Hoff factor, right? Okay. So now, the formulas that we are going to talk about is for when you talk about the weak electrolyte, right? That is when you have degree of dissociation or association as alpha. Now, if you talk about association, in that case, you will have I is equals to 1 plus alpha by n. If you talk about dissociation, in that case, I, Van't Hoff factor is equals to 1 plus alpha plus n alpha, right? Now, in association, your this Van't Hoff factor is less than 1. In dissociation, Van't Hoff factor is greater than 1, right? In association, it is less than 1. In dissociation, it is greater than 1, right? Understood this thing? Now, from here also the questions are asked, right? So, whenever they talk about a weak electrolyte, they will give you some value of alpha. You will put the value of alpha. For example, they are talking about any weak electrolyte like CH3, any weak electrolyte, let us say BaOH twice. Again not. So, let us talk about MgCl2, right? They are talking about a weak electrolyte. The weak electrolyte, they are saying that we know that the number of particles in which it will be dissociating is 2Cl negative, that is 3 particles it will be dissociating in, right? So, N will become 3 because it will become 3 particles, right? And alpha, for example, they have given you alpha as 40%. If they have given you alpha as 40%, that means 40 by 100, it will become 2 by 5. So, alpha will become 2 by 5. So, you will put the value of alpha, you will put the value of N here. In dissociation, alpha and 1, you will get the value of I from there, right? But if you are talking about association like acetic acid, right? So, we are talking about association, alpha will be given to you 40%, 30%, whatever, right? N will be number of dimerization, number of associations. For example, it is a dimer. Dimer means 2 molecules, so N is equals to 2. For trimer, it is N is equals to 3. For tetramer, N is equals to 4, right? Okay, this is how you are going to solve this question, right? Non-electrolyte like urea, I is equals to 1, right? Now, important points about I. More is the value of Van't Hoff factor, more is the deviation in colligative property, because colligative property is directly proportional to the Van't Hoff factor. Next is, it means more the number of ions given in one molecule, more is the depression and freezing point. More is the ions given, more is the value of I, more is the colligative property. It means more is the ions given by one molecule, more is the elevation in boiling point. It means more is the number of ions given, less will be the vapor pressure. Now, this is a very, 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 very important thing. Right? Right? What they are saying, it means that more the number of ions given, because this is P minus P naught by P naught is equals to I this. If this is less, the vapor pressure, the relative lowering, you can write one thing, more will be the lowering in vapor pressure. If I is less, if I is more, then relative lowering in vapor pressure will be more. But if I say this is your constant, this is your constant, if this is constant, this is constant, this is constant. Okay, I'll just write it on the next page. For example, you are saying P naught minus P by P naught is equals to I chi naught, right? I am saying if I increases, then this whole term will increase. Relative lowering in vapor pressure will be more. If this is more, this whole term is more, then that means this term is less. Why? Why? Because this alpha, this decrement is less. If I am saying 5 minus 2 is equals to 3 and 5 minus 3 is equals to 2, I am saying that this whole term is more. Out of this, the subtraction is more. The subtraction means 3 is more. If 3 is more, that means the amount that we have subtracted is less. So that means 2 is the less quantity, right? So if this is more, this whole term is more, that means the vapor pressure to which it has decreased is less, right? Okay, that is why this becomes very, very important. Okay, understood this point? It's a very, very important point, right? Okay. Yes, now let us see the questions based on this. Van't Hoff factor, they are saying the Van't Hoff factor for dilute aqueous solution of the strong electrolyte of barium hydroxide, right? Barium hydroxide, right? Strong electrolyte it is. It is going to give us Ba2 positive plus 2 OH negative, right? Strong electrolyte means alpha is equals to 1. So N is equals to 3. Why? Because you have 3 ions after dissociation. So in strong electrolyte, I is equals to N is equals to 3 only. So answer is your 3 is the correct answer. That is D will become the correct answer, right? Okay. Next question again a very important question that says, the following solutions were prepared by dissolving 10 gram of glucose, 10 gram of urea, 10 gram of sucrose. They are asking you the osmotic pressure. Now pi is equals to CRT. What is concentration? That is number of moles of solute by volume into RT. Now volume is same, 250, 250 and 250. Right? Gram is also same. If you want to write it in the form of gram, that will be W2 by M2 into volume in liters multiplied by RT. Right? Now we have seen that volume is same. Weight is also same. This is 10 gram, this is 10 gram, this is also 10 gram. So volume is same, weight is also same, R is so definitely same, temperature is also, they are telling you it is same only. That means pi is inversely proportional to mass of solute. So more is the mass of solute, less is the osmotic pressure. So just have to see the mass of the solute, right? So maximum is for sucrose, then you will have for urea the mass will be this or this. Yeah, for glucose it will be more, right? So mass we can say that sucrose has more mass. Sucrose means third one. Sucrose means third one. Sucrose has more mass. Then let us say, I'm just writing sucrose has more mass. Then you have glucose. Then you have urea. Then you have urea. Right? Then you have urea. So pressure will be opposite. This is 3. Glucose is what? 1. Glucose is 1 and this is 2. So pressure will be opposite. This is 3. This is 1. This is 2. Pressure will be this. So 3, 1, 2. 3, 1, 2. 3, 1, 2. That means 2, 1, 3. If in decreasing order it is 2, 1, 3. 2, 1, 3. That means A will become the correct answer. Right? A will become the correct answer here. Right? This is NEET 2021 question and it is a very simple question. Okay? It is a very simple question. Okay? Yes? Yes, everyone? Now, before going, I told you that we will see the abnormal mass in the end. Right? Abnormal mass in the end. See one thing, now you know the concept of dissociation and association. I'll just ask you one thing here. For example, you were thinking about 100 NaCl, right? And now you have, all of them has been dissociated. Now you have 100 Na and you have 100 Cl. So normally you will pick out one ball. You were talking about 100 balls. Now you have 200 balls, right? So you'll pick out one ball and you will see the mass of that, right? According to you, that means the normal mass that is given by the formula of compound. Your normal mass of NaCl is going to be 23 plus 35.5. That is going to be the normal mass of NaCl. Because you will think, yeah, I have one molecule of Na, 1 molecule of Na will give me 1 mole of molecule of Na. That means the mass of 1 mole of NaCl will give you the molar mass, right? We will talk about, if you want to talk about one molecule, that means 1 molecule is going to give me the mass of 1 molecule, right? Okay, I'll think about that as my molecular mass. But now, here they are saying that dissociation has happened. Now, in reality, dissociation has happened. When I will pick this out, it will be less than that, because the mass of NaCl is definitely greater than Na or Cl. If I pick Na or Cl out of it, either I will pick Na or I will pick Cl, because now both of them are different balls, right? Both of them are different because they have dissociated themselves, right? So now when I pick one ball, either it will be Na or it will be Cl. That means that is your abnormal molecular mass, and that abnormal mass is by formula of colligative property. Formula of colligative property. Any colligative you talk about, relative lowering, you talk about freezing point, you talk about elevation and boiling point or osmotic pressure. When you calculate the molecular formula from that colligative property formula, you get abnormal molecular mass, which will have dissociation also, which will have association also. And definitely, if I talk about dissociation, if I talk about in the case of dissociation, earlier my one molecule will have mass of NaCl. Now my one molecule will have mass of either Na or Cl, which is definitely less. So that is why normal here is greater than abnormal. Normal mass here is greater than abnormal mass. Now tell me, is that clear to everybody? Is that clear to everybody? Yes. Now, if I talk about in the same way, if I talk about the next thing, that is dissociation. That is dissociation. Now, in dissociation, what will happen? Now, in association, what will happen? In association, what will happen? You will have your CH3COOH, two molecules will dimerize to form CH3COOH twice, right? Earlier I was talking about the normal mass, right? The normal mass. If I want to have the normal mass, what I will have? If I want to have the normal mass, what I will have? I will think that one molecule will have the mass of CH3COH, but because of the dimerization like this, because of the formation of this dimer, one molecule will have twice the mass of one acetic acid molecule. That means my abnormal molecular mass is more. Now, after association, my mass has increased, right? So, this basically normal is before association or dissociation, and this is after association or dissociation, right? This you will calculate from the colligative property. This you will calculate from the formula of the compound, right? Okay, understood this thing? Now, let us see the theory part. Ionic compounds, when dissolved in water, they dissociate. For example, if we dissolve 1 mole of KCl, we expect 1 mole of each K positive and Cl negative. If this happens, that will be 2 moles of particles. Because of that increase in this, all we know, colligative property depends on number of solute particles. That is why they will also change. When there is dissociation, the experimental determined molecular mass is always lower than the true value. I told you this, no? That your normal mass is greater than abnormal. This is what the same thing they are telling you. That your experimentally determined molar mass is always lower than the true value. That means experimentally determined. That means what we have calculated from colligative property, right? Experimentally determined means they are talking about abnormal, right? And true value means they are talking about normal mass that you will calculate from the formula itself. right? Formula itself. Such a molar mass that is either lower or higher than the expected or normal value is called the abnormal mass, right? So now if you talk about the accurate molar masses, this we have already done, right? Okay, if you talk about association, it will form dimer, and because of that also the molar mass calculated experimentally will be different than what we will expect from the formula, right? So that is called normal, abnormal molar masses, and that is why you will have this definition also, that normal molar or actual molecular weight, that is from the formula, that is from formula of compound, and this is from colligative property. This is from the formula of colligative property that we will do experimentally, right? That we will do experimentally. Normal or actual formula of compound divided by abnormal, that is normal divided by abnormal molar mass, right? Okay, understood? For example, for acetic acid, I want to know I is equals to, normally I am thinking about one molecule. I'll think about one molecule, right? So normally I'll think about one molecule, but in reality it will become 2. So that is why I is equals to 1 by 2, right? That is why I is equals to 1 by 2. If I talk about I for NaCl, I will think about, wait a minute. I think, yeah, that's it. Yeah. So if you talk about NaCl, for NaCl, you have this thing, Na plus Cl, Na positive, Cl negative. But for this one, you have CH3, COOH, and this will dimerize into CH3, COOH twice. These are the two things that we were talking about. Okay? Chalo. Now I think, guys, that's all about your solution chapters, right? So basically you need to understand the formulas of colligative properties, right? These 4 formulas are important for you, right? Concentration terms like molality are important for you. Then what is reverse osmosis, all of those things. And then these kind of questions, right? These kind of questions where we are talking about the Van't Hoff factor, we are talking about dissociation, we are talking about number of particles there, and these kind of questions which involve the degree of dissociation or the association. Okay? Yes? Understood? Chalo. Okay? Yes. Books for organic, just need to buy this book, that is Tejas book. It has everything in it, right? So basically inorganic, organic and physical, if you want to practice, that is the best book, right? Okay. Okay then, bye bye, take care students, and all those students who are talking about she is coming. So students, she is this, where you will get your offer on flashcards, that is totally off. Earlier you were getting it for 2000, now you are getting it for 1321. And what are flashcards? These are the flashcards, as you can see here. These are the flashcards, right? In these flashcards, you will get short notes, right? You will get short notes. Like in this, it's a very beautiful, like very, very beautiful. You are very lucky to have these things, right? Because the conclusion of all the chapters are given in these flashcards. You just have to see this. You will revise everything from these flashcards. So it's a very, very important thing to purchase, right? And next is your Tejas books, as I've already told you. If you want to practice, because now is the time for revision and practice, right? If you want to practice, this is the best thing, best book to purchase to practice questions. Here you will have NCERT based question, you will have short theory, right? Everything is given to you. Then you have, if you want to, like, okay ma'am, I'm purchasing Tejas book, I also want to have DNA batch. So there is this combo where you have DNA as well as the Tejas books. Okay? Yes? So instead of burning your money on crackers, I would say invest your money into something good, something useful, which is going to be very fruitful in coming 6 months, right? Okay, and now is the best point to start your practice, right? After 2-3 months also, like you will have less time to work on your mistakes. Now you will, even if you do mistakes, you will have time to work on that, right? So I think that is the best time for your practice, right? Give as much as questions that you want to do. Be quick, fast. Yes. Okay. Chalo. Okay then students, bye-bye. Take care. See you all in the next class. Bye-bye. Take care. Yes, advance happy Diwali to everyone here. But I am going to take your class tomorrow at 10 a.m. for chemical kinetics. So I'll see you all tomorrow at for chemical kinetics on this channel itself. Okay, bye-bye. Take care. See you all tomorrow. Bye-bye.